Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P0100, indicates a malfunction within the mass airflow (MAF) sensor circuit in the 2023 Plus Honda CR-V. This issue usually arises when the MAF sensor's output frequency falls below a specified threshold, signaling to the powertrain control module, PCM, that something is wrong. The PCM is responsible for processing information from various sensors to manage engine functions effectively. The MAF sensor, located in the intake system, measures the amount of air entering the engine, which is essential for maintaining the correct air-fuel mixture. A malfunction in this sensor can lead to decreased engine performance, increased emissions, and potentially trigger the check engine light, CEL. Understanding the underlying components and their locations is critical for effective troubleshooting, especially in modern vehicles like the CR-V, where electronic systems play a huge role in operation. The MAF sensor plays a pivotal role in calculating the mass of air entering the engine, which is vital for the engine management system controlled by the PCM. Its location is generally found in the intake air duct, between the air filter and the throttle body. When the sensor fails or the circuit experiences malfunction, the PCM cannot accurately determine the needed amount of fuel, leading to potential operational issues. This malfunction is indicated by the DTC P0100, which informs the technician that the frequency of the sensor's output is lower than expected. The issue could lie within the MAF sensor itself, the circuitry connecting it to the PCM, or even within the PCM. Understanding these interconnected components makes diagnosing and resolving the issue more manageable. There are several possible underlying causes of DTC P0100. Firstly, shorted circuits within the wiring can lead to improper signals sent to the PCM, resulting in a malfunction. These shorts may occur due to wear and tear, abrasion, or environmental factors affecting the insulation. Secondly, a faulty MAF sensor itself can produce erratic or low-frequency readings, directly affecting the vehicle's performance. Lastly, another potential source of this DTC is the PCM, which may also malfunction and fail to process the input properly. It's crucial to methodically check each potential cause in order to isolate the issue effectively, ensuring the right measures are taken to restore proper function. Symptoms associated with DTC P0100 can significantly impact the driving experience. One common sign is decreased engine performance. You may notice a lack of acceleration or power when trying to speed up. Additionally, the check engine light, CEL, will likely illuminate, indicating that there is an issue that requires attention. Finally, drivers may observe erratic idling behavior when the vehicle is stationary, potentially resulting in stalling or rough engine operation. Recognizing these symptoms early can lead to a more efficient diagnosis and repair process, preventing further complications down the road. The first troubleshooting step involves inspecting the external circuit connections linked to the MAF sensor and the PCM. It's vital to begin this process methodically, ensuring that all electrical connections are secure and free from corrosion or damage. Specifically, you'll want to check the Voltage Common Circuit 2, VCC2, Sensor Ground 2, SG2, and Fuel Gauge Pressure Circuit, FGP, for any faults. Confirming there are no shorts or breaks in these circuits is imperative, as any irregularities could lead to the issues currently being faced. If any problems are found during this inspection, rectify them accordingly, as they can directly affect the functionality of the MAF sensor. Moving on to the MAF sensor inspection, this step necessitates a comprehensive evaluation of the mass airflow sensor and the intake air temperature IAT sensor. The condition of the sensors can often be diagnosed by measuring the output frequency and comparing it to manufacturer specifications. During this phase, it may be beneficial to use a known good component for testing, allowing for straightforward identification of any faults within the existing MAF sensor. If you find that the MAF sensor is producing values below acceptable limits and fails to meet the necessary specifications, it is likely that it indeed requires replacement. If the previous inspection steps yield normal results, the next step is to inspect the Powertrain Control Module, PCM. The PCM is essential for engine management as it processes input from various sensors, including the MAF sensor. To determine if the PCM is functioning correctly, thorough testing is necessary. You may find that validating its operation through various diagnostic tools and methods, as outlined in the vehicle's repair manual, is essential. If all other components are functioning correctly, and the PCM shows abnormal outputs or fails to respond, its failure may be confirmed, indicating that it will require replacement to resolve the DTC P0100 issue. After completing the necessary repairs or component replacements, it is crucial to verify that the repairs were effective. Start by thoroughly restoring all electrical connections to ensure that they are secure and functioning correctly. Once connections are restored, you must clear the DTC from the PCM so it can reset and monitor the vehicle's performance without previous fault codes interfering. Conducting a test drive is essential to confirm that everything is functioning as expected and that the previously illuminated check engine light is no longer triggered. This verification step is a fitting end to the diagnostic and repair process, ensuring that the vehicle operates smoothly. Preventive maintenance plays a vital role in avoiding future occurrences of DTC P0100 and ensuring the longevity of your Honda CR-V. Regular inspections of the MAF sensor and its associated connectors can help identify issues before they escalate, ultimately enhancing vehicle performance. Additionally, checking wiring harnesses for wear, fraying, or corrosion is beneficial as these factors can lead to electrical problems that affect sensor readings. Routine engine checks, including a comprehensive evaluation of the intake system, can further assist in maintaining optimal vehicle health. These proactive measures will contribute significantly to extending the lifespan of both the MAF sensor and the PCM. In summary, properly diagnosing DTC P0100 requires a thorough understanding of the components involved, such as the MAF sensor and PCM. Each step in the troubleshooting process builds on previous findings, leading to a methodical approach that helps isolate the issue effectively. Awareness of the potential causes and symptoms can expedite repairs, improving overall vehicle reliability. Moreover, implementing regular inspections and preventive maintenance will not only help avoid future occurrences of this DTC, but also optimize performance and longevity of the Honda CR-V. Staying proactive allows owners to drive confidently, knowing their vehicle is well maintained and carefully monitored. Please like and subscribe to the channel. See you next time.